So I said the flash drought typically begins with a precipitation deficit and grows more rapidly than normal, so the definition is not unique in that sense. But this nice paper by Kingsley Mo and Dennis Lettmeyer, they wrote a paper on the prediction challenge of well, that's a different paper, but nonetheless this paper looked at the challenge of predicting flash droughts at subseasonal to seasonal time scales. If flash droughts can intensify very rapidly, and global warming is going to make it worse, because as temperatures warm, the atmosphere gets more thirsty and then begins to drive evaporation, which can rapidly drop soil moisture below the threshold where crop stress can set in, and then it becomes the agricultural drought. And I'm saying that because it can start not just with precipitation deficit but also with a heat wave, for example, and we will see that example here. So this is showing energetic considerations. So here is evaporation rates, which could be evapotranspiration, which is basically evaporation mediated by vegetation. So vegetation takes up water through its roots, opens its stomata, and loses some moisture. So the local moisture budget is controlled by that evapotranspiration, and there is of course the baseline evaporative demand E0. And this is a figure that's showing drought development time split into a time period where the soil moisture is high enough, it's available so that the energy that is evaporating or driving evapotranspiration is not enough to take up all the soil moisture. So evaporative demand can grow, but the soil moisture is still available, and evapotranspiration is right there. So evapotranspiration is basically almost equal to evaporative demand E0, which is dependent on winds, atmospheric temperature, and vegetation types, and so on and so forth. And you can see that at some point the drop in the soil moisture below a certain percentile, so the soil surface moisture availability here drops, and below whatever threshold, then the evaporative demand crosses over and becomes greater than the available soil moisture. Obviously that will drive down the evapotranspiration, which is what we call vegetation stress. So here it is moisture, the processes are moisture limited because the energy is high, evaporative demand is actually greater than evapotranspiration, and then you can have feedback from drying land surface which can raise the evaporative demand. So then you get into this intensification rates which are very rapid. So this is the response of evaporative demand and evapotranspiration to feedbacks from drying land. This is just a schematic evolution of evaporative demand E0, evapotranspiration, and surface moisture availability, starting from a wet energy limited left side state which has enough water for ET to further increase if additional energy is added somehow. Atmosphere is getting warmer, or could be even that precipitation is dropping, and this has enough water for ET to which has enough water for ET to further increase if additional energy is added to the surface, and developing into a dry water limited regime on this side. So this is from that reference from this paper 2089 or whatever. And the example shown here is a flash drought that occurred here in the northern Great Plains in May 2017. So this is showing the relative rank of precipitation over the period of 1895 to 2017. So May 27 was the driest. These colors here are the driest recorded over this period, and then it ranges to other scales here. But you can imagine just what kind of a once in a century type uh, flash drought it is. And this is showing here soil moisture percentages, and you can see percentile, sorry, you can see that it's very moist. Soil moisture is quite wet, and then there is this very rapid drop to below 20th percentile. It goes up and down, but basically remains very low for several pentads, several months, and then there is a storm coming by and it jumps back to the pre-flash drought kind of period. And this is showing the precipitation here, and you can see that even though the precipitation came and recovered the soil moisture, with respect to the long-term climatology, basically precipitation was deficit even through the end of October here. So this is why we have to consider the metric carefully, because here precipitation is deficit, but soil moisture percentiles have jumped back up. Okay, so that is what determines the agricultural droughts. A farmer always wants to see not how much total precipitation fell, but how much soil moisture loading happened, right? So this is showing the maximum temperature, and the seasonal cycle climatologically warms into the summer season anyways, but there were many periods above normal daily maximum temperatures during this drying or the flash drought, and you can see this extended period of warm conditions that crashed the soil moisture to below 20th percentile here. So this is the Kingsley-Moe Lettenmeyer paper that I wanted to mention before. So this is that paper here. This is looking at equitable threat score. So they did flash drought forecast experiments. I am not going to talk so much about the skill and so on, but I just wanted to show that there are flash droughts which can be created by heat waves, so not necessarily precipitation deficit. So this is showing equitable threat scores for heat wave flash drought during this particular period, April, May into August, September. So it's showing for different lead times. So lead 1 in April, May, lead 1 in June, July, lead 1 in August, September, and so on. And for each period, there is also lead 2 and lead 3 that are shown. And these are pentads here, sorry, 1 pentad, 2 pentad, and 3 pentads. So very much the subseasonal timescale predictions that we have mentioned before. So you can see that the equitable threat score is bit of a complicated metric, but they are basically using Global Ensemble Forecast System version 2 to make these forecasts, where the atmospheric model at some high resolution is run with boundary forcing that is either from the coupled forecast or some kind of initial or some kind of a boundary forcing given from some approach. Okay, so what I want to use these diagrams for is to basically mention that flash drought forecast experiments are being done now, and they are looking at flash droughts that may be created by heat waves, or they may be created by precipitation deficit. So this is looking at the same season and same lead times, and looking at precipitation deficit flash droughts compared to the heat wave flash droughts, and you can see the locations of the heat wave flash drought and the precipitation flash droughts are different, and the initial conditions are from different periods. Okay, so I will leave it there, because all I want to say is that flash drought doesn't yet have a very unique definition. It has to be region specific, so it makes sense to have a different definition for India versus the US, or maybe even within the US a different definition for Florida versus the Great Plains and so on. But one has to be maybe also be aware that you can define a flash drought and forecast it, but if it has no impact, maybe nobody cares. So it has to be impact based. Typically it's soil moisture focused, which means and temperature focused, which means it's typically agricultural drought that you are looking at. So intensification rates are critical, and then you can develop ways to mitigate the flash drought by monitoring soil moisture. So soil moisture becomes very critical in near real-time monitoring, and most places do not have a very good soil monitoring network, especially a country like India. And satellite data is either not available in near real time, or the resolution, spatial resolution and temporal resolution are not enough. So forecast problem is a big challenge for flash droughts, but in this context of monsoon extremes, I wanted to include this just to say that monsoon extremes doesn't mean just precipitation excess extremes, but also precipitation deficit extremes. And depending on where you are within India, within the monsoon season, you may have heat wave driven flash droughts, which may happen maybe in the pre-monsoon period, but also during the monsoon period in, let's say, regions like the northwest, where the precipitation is climatologically very low, and then they may have flash drought that is not so much precipitation driven but could be temperature driven. So these are the challenges of flash droughts. Okay.